Welcome back, dear friends. Today we'll solve problem 5.81. So in this problem it is given that three steel plates are welded together to form a beam as shown. So this is the beam, you can see this is plate 1, this is plate 2 and this is plate 3, and they are welded together to form a beam. Knowing that allowable normal stress for steel use is 22 ksi, determine the minimum flange width B that can be used. So minimum normal stress is 22 ksi, so you have to find the minimum width of the flange. So this is, you can see this plate is known as flange while this plate is known as web. So you have to calculate this minimum width B that can be used. And the beam that is shown AB is simply supported beam. At point B we have a point load of 8 kips, at point C we have 32 kips, and at point D we have 32 kips. All the given data has been written, that is sigma allowable is 22 ksi, and what we have to find is minimum flange width B. So let's move and solve the problem. First of all, you know that we have to find the reaction forces at point A. So for that I have to replace this support with the reaction support, and this is equal to RA. And at roller support at point E we have also a reaction force that is known as RE. So what we have to apply equilibrium condition. We have to take whole beam as free body and apply the equilibrium condition. So first equilibrium condition, that sum of all moment about point E is equal to 0, and taking the counterclockwise moment as positive. So we are taking the moment at point E. So moment due to this force will be this force, will be this force, and this force. So this RA into perpendicular distance is this one. For this force the perpendicular is this one, and for this perpendicular distance is this, and for this force perpendicular distance is this. All the upper three forces will produce counterclockwise movement, while this RA will produce clockwise movement. So we will write that. So let's move and write it. RA into perpendicular distance, this whole distance is 45 feet, 42 feet. This is this total distance. If you sum this is 42 feet. Clear? So RA into perpendicular distance is 42, and this is producing clockwise, so it will be minus. Now 8 into perpendicular distance, which is this one, I will show you from this to this distance is 37.5. So 8 into 37.5, and this is producing counterclockwise movement, so it will be positive. Again plus 32 into perpendicular distance is 23.5. I will show you from this to this distance, this total is 23.5. And the last one, which is 32 again, plus 32 into perpendicular distance is 9.5. Their sum must be equal to 0. So when you solve this, you will get RA will be equal to 32.28 kips. Now we have this value, reaction force at point A. Now we will apply the another equilibrium condition, that sum of all moment about point A is equal to 0, and taking the counterclockwise moment as positive. So you can see our focus is point A. So one force which is producing movement is this one, and this will be clockwise. The second one is this force and perpendicular this distance, and it is also producing clockwise. The third force is this and perpendicular distance, and it is also producing clockwise, while this RE and perpendicular distance is this is producing counterclockwise movement. This movement produced by RE is positive, while their movements shown here it will be negative. So let's write it. RE into perpendicular distance is 42, and it is producing counterclockwise movement, so it will be positive. Minus 32 minus 4.5 minus 8 into 4.5, this one. Now 32 minus 32 into perpendicular distance is 18.5. 18.5 from this to this distance is 18.5. Clear? And the last one is minus 32 into perpendicular distance. Minus 32 into perpendicular distance is 32.5. So their sum must be equal to 0. So from here you will get this RE will be equal to 39.71 kips. 39.71 kips. Now you have both the value of RA and RE. You can find the shear forces. We will move towards shear forces. So shear forces, I have drawn the sketch over here. You can see the beam is shown, all the loads are shown, and we will plot the shear force on shear force diagram. This is AB, this is BC length, CD and DE. One division here is taken as 10 kips, so this is 10 kips, 20, 30 and 40. On y-axis we have kips, shear force, and on x-axis it is the length. So you can see that RA is equal to, we have RA is equal to 32.28 kips and RE is equal to 39.71 kips. So we'll start from point A. So from A to B, you can see here, I will show you that A is equal to, RA is equal to 32. So from A to B there will be no load, so it will be remain 32. So I will write it from A to B. Shear force is 32.28 kips. Clear? So I will also draw it from here, 32. So RA, this is 30, this is 40, so 32 will be somewhat here. So this is the point. So from A to B it will be same. So we will draw it by using a horizontal line. Now you can see that at point B we have a loads of 8 kips, and that is downward minus 8. So you have to subtract, the load will change at point B. So 32 minus 8 will be equal to 24.28. So again 24.28 will be somewhat here. Clear? So the load will change from B, the load will change like this. Okay, now from B to C, moving from B to C, you can see there is no load, so load will remain same. So from B to C, the load will be, again that will be 24.28. 24.28 kips. I will mention it. This is 24.28. Okay, now from B to C, this is C point, so the load will remain same, so it will be horizontal line. Now you can see that at point C we have a load of 32 kips also, and that is downward. So 24.28 minus 32 will give you minus 7.71. So you have to plot minus 7.71. This is minus 10. So 7.71 will be somewhat here. So I will draw a vertical line. Clear? Now this is minus 7.71 kips. So again from C to D, you can see from C to D there is no load. So from C to D, this will be equal to minus 7.713. Okay. Now from C to D the load is same, so I will draw horizontal line. Now at point D we can see that we have a load of 32 kips. So minus 7 and minus 32 will be equal to minus 39.71. So this is 20 minus 20, 30, and this is 40. So it will be somewhere here. So let this is minus 39.71. So load from D changes to minus 39.71. And again from D to E you can see that the load is same. So this will be a horizontal line. So this is your shear force. I will write from D to E. D to E the load is minus 39.71 kips. Okay. I will also point out this load is 32.28 kips. At this point this load is 24.28. At this point this is again 24.28. At this point this is minus 7.71 kips, and this is 39.71 kips. So this is your shear force diagram. Now we will move toward area, because from area under the shear force diagram will give you the bending moment. So area from A to B, from A to B. So let me show you. This is area under AB. This is the area under AB, this rectangular, and the area will be height, this height multiplied by this width. So height is 32.28 and width is 4.5 feet. So area will be equal to 4.5 feet into this height, which is 32.28. 32.28, and that will give you 142.286 kips into feet. Now area from B to C. So what is the area from B to C? So from B to C we have this area. So width is this one, which is 14 feet, and height is this one, which is 24.28. So I will write 24.28 multiplied by width is equal to 14. So this area will give you 340 kips into feet. Now from C to D, I will show you from C to D. This is the area under CD. So width is this one, which is 14 feet, and height is minus 7.71. So minus 7.71 into 14 will give you minus 108 kips into feet. Now the last one from D to E, the area will be this one. I will show you from D to E, the area will be this one. This is the area from D to E. So length is 39.71 and width is 9.5. So let me write it. Minus 39.713 into length is 9.5 feet, and it will give you minus 377.28 kips into feet. Now by using these area we will be able to plot the bending moment diagram. So let's move and plot it. Okay, so I will first write bending moment. Let's choose another color. Bending moment. So first movement about point A. What will be the movement about point A? So movement about point A will be 0 because x is equal to 0. So movement about point A is equal to 0. Now movement about point B is equal to movement about point A, which is 0 plus the area under the curve from A to B. So it is the area under curve from, so this is 1 plus 142.286. So it will be 142.286 kips into feet. I will plot it on the spot. So this is 100. This will be 142 will be somewhat here. This is 150. So 142 will be somewhat. I will also write 142.28. Okay. Now movement about point C. Now movement about point C is equal to movement about point B plus the area under the PC. So this is the area and the value is this one. So it will be 340. I will write 340. So MB is 142.28 plus 340 will give you 485.29 kips into feet. So let me plot it. 480. So this is 480 will be somewhat here. Okay. Movement about point D is equal to movement about point C, which is equal to 485.29 plus the area under the curve CD, which is minus 108 kips into feet. And when you solve it, you will get 377.29. So movement about point D is 377.29. So 300 is there. This is 400 and so 377 will be somewhat here. Now movement about point E, which is equal to 377.29 movement about point D plus the area under the curve, area under the shear force of CD. This area, which is minus 377.28. So minus 377.28. So that is equal to 0. So this will be your last point. So this point is 142.28. This is 485.29 kips into 8. This is 377.29 and this is 0. Now you can join them by using a line. So from A to B, this will be a straight line because you can see that shear force is a constant line with 0 degrees. So bending moment will be 1 degree higher and it will be a straight line. Same is the case that from B to C, it is a line with 0 degree slope. So the bending moment will be the first degree line. So from B to C, you have to join them by using a straight line. Okay. Also from C to D, you can see this is a straight line, but that is in negative. So you have to decrease the slope. So again, you have to join these two lines, these 2 points. Now from D to E, again this is negative, so slope will be decreasing, but it is a first degree line, so you have to join D and E. So this is your bending moment diagram. Now From this diagram you can see that we have maximum bending moment is 485.29. So I will write it maximum bending moment, maximum bending moment is equal to 485.29 kips into feet. And in term of inch, you have to multiply 1 foot is equal to 12 inch, so you have to multiply 12 with 485.29. It will give you 5.28 into 10 raised to power 3 kips into inch. And also sigma allowable, which was given in the data in the question, that is sigma allowable is 22 ksi. So 22 ksi. So from here we know that allowable stress or stress is equal to m divided by section modulus, m divided by s. So from here you can see that s is equal to maximum bending moment divided by the allowable stress. Okay, so put the value. You have maximum bending moment is equal to 5.28 into 10 raised to power 3 kips per inch, and allowable stress is 22 ksi. So 22 into 22. Okay, so when you calculate it, you will get S minimum, because sigma is allowable, so S minimum will be equal to 264.70 cubic inch. So this is the S minimum. Okay, now we have been given that the beam having this dimension. This is, if I draw it below, you can just see that this is B, this is 1, this is 19, this is 1, and this is 3/4. And we will calculate its moment of inertia. So let me draw it over here. I will draw it over here. So this is the top flange having width B. This is the web, and this is again the flange. So this thickness was 1 inch. Let me check. This is 1 inch. This web thickness is 3/4 inch. This total, this from this to this height is 19 inch. Clear? And again this is 1 inch, and this is the beam. So we have to calculate the moment of inertia for this. As we know that moment of inertia I is equal to, now you can see that we have one plate is this, the second is this, and third one is this. So if I draw the centroidal axis, so it will be at the half. So we have to I2 plus 2 times I1, because I1 is equal to I3. So what is I2? I2 is for the mid of the web plate. So it will be equal to BH cube. So B is this, H is this. So I will write it is equal to 1/12 BH cube. So B is this 3/4, and H is 19. Clear? This 19. So 19 whole cube plus 2 times, because we have 2 times I. What is the moment of inertia of I? So you can see that it will be B B is this one and H is this one. So first we will write 1 over 12, 1 over 12, B into height is 1 cube. Now plus you can see that since this area is at a distance from centroidal axis, so its half will be at a distance of 0.5 and this will be your D. So this is area, this is the area A plus AD square. So we have to write AD square over here with. So area is what? Area is B into 1 and D square, and D is equal to, from here this will be the D, and this is 10 square. How it is 10? Because I will show you that the half of 19 will be from this to this will be 9.5 and this half is 0.5. So total is 10. So this D is equal to 10. Okay. So from here you will get the moment of inertia, and this moment of inertia, after solving it, you will get this I is equal to 428.69 plus 200.17 times B. And from here you can also check that C is the distance from neutral axis to the topmost. So this is C and this C is equal to 10.5. How it is 10.5? Because this distance from here to here is 9.5 plus 1 inch. So this total distance will be equal to 10.5. So I will also write here C is equal to 9.5 plus 1, which is equal to 10.5 inch. Okay, so we know that section modulus minimum is equal to I divided by C. Okay, so S minimum is 264.70 is equal to I, which is equal to 428.69 plus 200.17 times B divided by 10.5. So it will be equal to 40.82 plus 19.06 B, and that is equal to 264.70. So when you calculate it, you will get this breadth B is equal to 11.74 inch. So this is the value or breadth that you can be selected. This B is equal to 11.74 can be selected for the safe beam for the given loading. I hope you have enjoyed this video. Again, if you have any question, you can ask me in comment section. Also tell me how I can improve my videos further, and your feedback will be also valuable and will help me in getting more and more excited videos. Thank you.